Hello viewers, in today's class we are going to discuss some important indefinite integrals in which trigonometric identities will be used, right? So in this lecture we will see how we can make use of different trigonometric formulas or identities to evaluate integrals, right? So the first problem is to find the integral of sine 2x cos 3x, right? So here if we see that our integrand is sine 2x cos 3x, right? So here we have the product of sine function and cosine function, right? So in order to integrate these type of problems, what we will do, we will use the identity which is 2 sine a cos b is equal to sine a plus b plus sine a minus b, right? So see, here we have the product of sine function and cosine function, right? And the product of sine and cosine function is converted into the sum of two sine functions, right? So here our integrand is of this form. So let us call this integral as I. So we can now write I as half. We can multiply this integrand with the 2 and divide it by 2, right? So in order to get this form 2 sine a cos b, so we can now write half 2 times sine of 2x and cos of 3x, right? And now if we compare this expression with this one, we can easily see that a is equal to 2x, right? So this is our a and this is our b, right? So b is equal to 3x. Now if we apply this rule to this expression, then we can have half integral. Now we have here sine a plus b, right? Because this form is of the form 2 sine a cos b, right? So we have sine a plus b. So a is 2x and b is 3x, right? And then we have sine a minus b. So we can now write sine 2x minus 3x, right? Okay, so now we have converted this expression, the product function of sine and cosine, into the sum of two sine functions, right? So we have half, and now we can write sine 5x here, because 3 plus 2 is 5, and here we have a sine of minus x, right? Okay, now from trigonometry here we have one more important result which says that sine of minus theta is equal to minus sine theta, right? So sine of minus x can be written as minus sine x, right? So we can take out this negative sign outside. So now we have these two terms, right? And now we know that the integral of sine a theta is equal to minus 1 over a cos of a theta, right? And the integral of sine theta is equal to minus cosine theta, right? So now we can write this integral as half. The integral of sine 5x is minus 1 over 5 cos of 5x, and then we have the integral of sine x as minus cosine x, right? And c is the constant of integration, right? So we can now write it as c, if we multiply these two terms with half, then we'll get minus 1 over 10 cos of 5x, and then here minus becomes plus, so we have plus half, and cos of x plus c, right? So the integral of this function is equal to this expression by making use of this identity along with these results, right? So let us now take the second problem. So now let us take this problem, and here we have to find the integral of cosine cube x, right? Now here if we see that we have the power of cos x as 3, right? And we do not have a direct integral for cosine cube x. So here again we'll make use of an important identity from trigonometry, right? And we'll use the result for cos of 3x, in which cos of cube x appears, right? So cos 3x can be written as 4 times cos cube x minus 3 times of cos x, right? So here we see that we have this term cos of cube x which appears here. So now if we simplify this expression, see, we can write cos 3x plus 3 cos x is equal to 4 times cos cube x, right? And now if we divide both sides by 4, then we have 1 over 4 cos 3x plus 3 over 4 cos x, and this is equal to cos cube x, right? So now for cos cube x we have this expression, right? So now this integral I can be written as integral, and for cos cube x we can write this expression. So we have 1 over 4 cos 3x plus 3 over 4 cos x and dx, right? Okay, so now we have here two terms, and we can write this integral as 1 over 4 and cos of 3x dx, and here we can write 3 by 4, and here we have cos x dx, right? And now we have the direct results for the integral of cos 3x, and we can write 1 over 4 the integral of cos of a theta d theta is equal to 1 over a sine a theta, right? And the integral of cosine theta is equal to sine theta, right? So here we can write 1 over 3 because the value of a is 3, and we have sine of 3x, and then we have 3 over 4. The integral of cosine x is sine x, and here we have c as the constant of integration, right? So we can simplify it. So we have 1 over 12, 4 3s are 12 sine 3x plus 3 over 4 sine x plus c, right? So this is how we see that how we can integrate or find the integral of cosine cube x as this expression, right? Now let us take this problem. So here we have to find the integral of cos 2x plus 2 sine square x divided by cos square x, right? And again here we'll make use of an important trigonometric identity to first simplify this expression, and then we'll find the integral, right? So now here what we will do, see, we have a term cos of 2x, right? And from trigonometry we know that cos of 2 theta is equal to 1 minus 2 sine square theta, right? So this is a very important double angle formula for cosine theta. So cos of 2 theta is equal to 1 minus 2 sine square theta. So here what we will do, we'll substitute 1 minus 2 sine square x for cos 2x, right? So now cos 2x can be written as 1 minus 2 sine square x, right? Because cos 2 theta is 1 minus 2 sine square theta, and then here we have 2 sine square x, and in the denominator we have cos square x, right? And now we can easily see that minus 2 sine square x and plus 2 sine square x, these two terms get cancelled, and we are simply left with 1 over cos square x dx, right? And 1 over cos square x is simply secant square x dx, right? And now we know the standard result for secant square x, that is 10x, right? So the integral of secant square x is 10x, and here we have the c as the constant of integration, right? So the integral of this function is equal to 10x plus c, and here we see that how we can utilize the result for cosine 2x which is given by this expression, and how we can simplify this integrand, right? Now let us take this problem. Here we have to find the integral of 1 over 1 plus cos x, right? And again we'll make use of the trigonometric identity to solve this integral, right? And see, here we have cosine of x, right? And let us first see some trigonometry before solving this problem. See, we know that cos of 2 theta is equal to 2 cos square theta minus 1, right? So this is an important result from trigonometry. So cos of 2 theta, that is the double angle formula, is cos 2 theta is equal to 2 cos square theta minus 1. Now see, here we want to have cos x, right? See, here what we will do, we'll replace theta by say x over 2, right? So if we replace theta by x over 2 in this result, see what we get. We get 2 times x over 2, and here we have 2 cos square. For theta we have x over 2, and here we have minus 1, right? So 2 and 2 get cancelled, so we are left with cos x is equal to 2 cos square x over 2 minus 1. Now if we take this negative sign to this side, we'll get 1 plus cos x is equal to 2 cos square x over 2, right? So now we can replace this 1 plus cos x by 2 cos square x over 2, right? So now this integral I, it becomes integral 1 over 2 cos square x over 2 dx, right? Now we can take out this half outside the integral, and for 1 over cos square x over 2 we have secant square x over 2 dx, right? Now in order to find out this integral, because we know that the integral of secant square theta is equal to tan theta, right? So here we have x over 2 for theta. So here what we will do, we'll take t is equal to x over 2, right? So we'll make use of the method of substitution. So t is equal to x over 2. So x is equal to 2t, and dx over dt, that is differentiating both sides with respect to t, will get 2 because the derivative of t is 1. So we have now dx is equal to 2 dt, right? So now this integral becomes half, and we have sec square t, because x over 2 is t, and for dx we can write 2 dt, right? And this 2 and this 2 get cancelled, and see, we get secant square t dt, and the the integral of secant square theta is tan theta. So here we'll have tan of t plus c is the constant of integration, and again substituting the value of t as x over 2, we have tan of x over 2 plus c, right? So the integral of 1 over 1 plus cosine x is equal to tan x over 2 plus c, right? Now let us take one more important problem. So here we have to find the integral of cos 2x minus cos 2 theta divided by cos x minus cos theta, right? So here again the integrand is a trigonometric function. So here we'll make use of an important identity from trigonometry, and we'll take cos of say 2y is equal to 2 cos square y minus 1, right? So here we have the important double angle formula, that is cos of 2y is equal to 2 cos square y minus 1. So see, here we have cos of 2x, right? So now we can replace this cos of 2x by taking x for y, right? So cos 2x becomes 2 cos square x minus 1, because cos of 2y is equal to 2 cos square y minus 1, and here cos of 2 theta, if we replace y by theta, then cos 2 theta becomes 2 cos square theta minus 1, and in the denominator we have cos of x minus cos of theta, right? Okay, so now we'll simplify the numerator. So we have 2 cos square x minus 1, multiplying these two terms by this negative sign, so we have minus 2 cos square theta plus 1, and divided by cos x minus cos of theta, right? So now see, this one and this one get cancelled, and we are left with 2 cos square x minus 2 cos square theta divided by cos of x minus cos of theta dx, right? And now if we take 2 common in the numerator and taking 2 outside the integral, we have 2 times cos square x minus cos square theta divided by cos of x minus cos of theta and dx, right? And now we see that here we have in the numerator the term which is similar to a square minus b square, because this is cos square x and this is cos square theta, and between these two terms we have the negative sign, so we have a minus b and a plus b, right? So now we can write this term as cos x minus cos theta, that is a minus b, then we have a plus b, and in the denominator we have cos x minus cos of theta, right? And see, this term and this term get cancelled, so we are now left with 2 times integral of cos x plus cos theta and d theta, right? And now we can write this term as integral cos of here we'll have the dx, and now we have integral of cos x dx plus see, here we have cos theta is a constant, so we can now take this cos theta outside the integral, and here we are left with only dx, right? And now see, the integral of cos x is sine x, and here we have cos of theta and integral of dx is simply x, right? And c is the constant of integration. So now we can finally write this expression as 2 sine x, and we have here 2x cos of theta plus c, right? So this is the required integral of this function, right?